Okay, so now that we've been experimenting with pendulums, let's take this just a little bit further so you can actually do some math related to pendulums, make some predictions without having an actual pendulum to swing. A few things just as a review. Reminder that simple harmonic motion is just a vibration or a wiggle that occurs over a period of time. Okay? It's always a repeating motion back and forth, but it happens in the exact same spot. Alright? It doesn't travel through a room, it doesn't, travel through the air or anything like that. It just goes back and forth in the exact same spot. And a pendulum is a perfect example of this. Okay? And like the one that I demoed in class on my desk, that was just a string with an object hanging from it, and that's the most common way to make a pendulum. So, a pendulum is an object that exhibits simple harmonic motion, usually made of a string with an object hanging. So what it does is it swings back and forth. Okay? And it keeps doing that over and over. Now, in real life, pendulums stop, but in our simulation, the pendulum keeps going. Right? That's because in our simulation, there was no friction. So, just a couple of terms. Make sure you are familiar with these. They're very closely related to each other. But a cycle is one complete back and forth motion, or one swing back to the starting point. So if you start from position A, you'd swing through B to C, and then at C it turns back around and goes back to position A. So those two arrows represent the entire cycle. And then a period is how long this takes. Alright? Period is always, the standard unit is always seconds. Alright? Granted, big, huge pendulums, periods could be minutes long, but they have to be pretty huge to get that high. So, first lab, you should be done with that by now, and hopefully you got the same results as everyone else in what you're supposed to get. Ideally, as length, so as all of these increase, period should increase as length increases. It should stay the same with mass increases, and angle, it even stayed the same. Now, I imagine most of you didn't match your predictions on those two. And trust me, that's a common thought before dealing with a pendulum. You would think that if you make it heavier, okay, it's going to have to fall faster, or that, if you pull the angle up higher, then it's going to take more time to go from, top to bottom. But what ends up happening is all of this is actually controlled by gravity. So the only thing that actually makes it change is length. So let's talk about that relationship. So if you need to find the period of a pendulum, this is the crazy equation. Alright? So we have T being equal to period. Alright? Because again, we've already used P for momentum and PE for potential energy, so we need another letter. Alright? And then pi, hopefully you know this from math class, but you can use pi on your calculator, or you can just type in 3.14. Either way works. The L stands for the length in meters, and G is the acceleration due to gravity. So if you need to rearrange this, and for part 2 in the lab you'll have to use this equation to solve for G, it's a little more complicated than what you're used to, so I'm just going to write it down rather than walking you through it, and explain just some of the key ideas to keep in mind. So, if you ever need to solve for length, it looks like this. T over 2 pi, and then you square that, and finally multiply by gravity. So gravity is not squared. So the correct order to do this is take your period, divide by 2 pi, which would be 6.28, and then square that number, and then finally multiply by 10. Or, in the lab, if you have to solve for gravity, you're going to have 2 pi over T squared times your length. Okay? So, and again, kind of like the other one, figure out 2 pi, divide that by your period, square that number, then find length. If you don't do it in that order, you plug everything straight into the calculator, you're probably going to end up having mistakes. All right? So I highly suggest doing it step by step. Do 2 pi divided by t, hit equals. Square that number, hit equals, then multiply by your length. If you realize that you're not getting answers correct in class when you start practicing with this, I have a feeling it'll come down to how you're plugging it in the calculator. Okay? So let's do a couple of samples. First one uses the equation as it is. So our knowns, our length is 5 meters. And gravity, even though it's not given to us, we always know is 10 meters per second squared. Our equation, t equals 2 pi times the square root 5 over 10. Oh, I skipped a step there. Of L over G, and then T equals 3.14 times square root of 5 over 10. Okay, you don't have to write in 3.14 for pi, because pi in and of itself does stand for a number. It's not a variable, but I'm just doing that so that you see. And then that ends up becoming, if you calculate it out correctly, so I kind of took this one step further before calculating. I had 6.28 times the square root of 0.5. Found the square root of 0.5 and then multiplied by 6.28 and got 4.4. And since we're solving for period, that's in seconds. Okay? So next one, something a little bit more complicated, is what is the length of a pendulum that has a period of 5 seconds. So we know that our period is 5 and G is 10. So that's our knowns. Our equation is going to be L is equal to T over 2 pi squared times gravity. So if we substitute in our knowns, we're going to have 5 over 2 pi squared times 10. Alright, and then again, make sure you do this stuff in a very consistent manner. Either make sure you're using parentheses appropriately, although a lot of times you'd also even have to put parentheses around the 2 pi. So it's a lot easier if you just do 5 divided by 6.28, take care of the 2 pi in your head, then square it, then multiply by 10. Alright, and when I say then, hit the equals button. So that ends up becoming 6.34, and since we were finding length, your units would be meters. Alright, so we will definitely be practicing with this more in class, but make sure you do the online assignment and bring your notes to class tomorrow.